In this video, now we are going to solve exercise 18.3. It's question number 1, part G. We need to have the sketching of the following graphs, indicate the y-intercept, label the x-intercepts where they exist, or give the position of one point on the graph. For this particular part G, we need to continue it exactly on the same pattern. We would be sketching its graph using a table of the values. So let's find that table of values, like for example, this x and then y. Let's substitute some of the values of the variable x independently. If we substitute x equals to -1, for example, so our equation would give us y equals to -2 times -1 squared plus half. So that would be -2 times 1 plus 0.5. So -2 plus 0.5, that is -1.5. So the value of y is -1.5. We have substituted the value of x to be -1 at our on, because x is the independent variable and we are not bound to take any particular values of this variable x. So that's what we have done it. Then -1 squared would give us -1 squared, that is -1 times -1. So the answer is going to be +1. So that's what we have written here. Okay, then if you substitute the next value of variable x to be 0, for that would give us y equals to -2 times 0 squared plus 0.5. So this would be 0 plus 0.5. That is the value of y is 0.5. So 0.5. Okay. In the same way, we need to substitute other values of a variable x. Let me substitute, like for example, x equals to 1 now. Then we can substitute x equals to 2 and so on. Normally, we can take 5 to 6 or 7 values. That is sufficient if it is not given in the question. So if I substitute x equals to 1, now x equals to 1 would give us -2 times square of 1 plus 0.5. So that is -2 plus 0.5, which is again -1.5. So -1.5 is here. Then let me substitute x equals to 2. So the value of y is going to be -2 times square of 2 plus 0.5. So that will give us -2 times 4 plus 0.5. So this is -8 plus 0.5, which is -7.5. So x equals to 2 corresponds to value -7.5. And if I take another value of x, let it be, let's suppose 3. So let's check it out. What's the answer we get? That would be this thing. X equals to 3. That means -2 times square of 3. So that is -2 times 9, which is -18 plus 0.5. That is -17.5. So -17.5 is the value of y corresponding to the value of x to be 3. So that is the table of the values that will help us to sketch the graph. Okay. Now if I sketch the graph, it would be something that actually I need to see. First of all, since it is required in the question, we need to indicate the y-intercept. To find the y-intercept, let me calculate its y-intercept to be y-intercept. Y-intercept is the point where x equals to 0. So I'm going to replace x equal to 0 into the given equation. That would give me y equals to -2 times 0 squared plus half. So that is 0.5. So the y-intercept is 0.5. Y equals to 0.5. Then to calculate its x-intercept, let me calculate its x-intercept as well. For calculating x-intercept, we need to put y equals to 0. So 0 equals to the given equation, which is negative 2x squared plus half. Okay, now solving it out, let me shift this negative 2x squared to that side. That would become positive 2x squared equals to half. And now shifting this 2 to the other side, that will get divided with this and would come here in the denominator. So we are having its value to be 1 by 4. X equals to 1 by 4. So taking the square root on both the sides, that will give us x square root equals to square root of 1 by 4 with a plus minus sign. So that is plus minus 0.5, either a positive 0.5 or a negative 0.5. So these are the x-intercepts. Okay, now we are done with this thing. Secondly, we need to see, since the equation has got a negative coefficient of x squared, which is negative 2, so its shape is going to be like this. Very well done. Okay, so we need to combine all these results in the form of a sketch. Okay, now we proceed towards sketching the graph. For sketching the graph, let me draw the axes. Okay, here we go. This is our y-axis and this is the x-axis, for example. Okay, now you see, I need to accommodate all these values of x and y. For the x, I need to accommodate the values from -1 till 3. So I can take this much distance along x-axis. So 1 here, 2 here, and then 3 here. Okay. Then for y, I need to see that I need to accommodate -17.5, and then the maximum value is positive 0.5. So I need to accommodate these values. So let me have a gap of, like, for example, 3, so that I can have this value 3. So below the x-axis, -3, then -6, -9, -12, -15, -18. So that would be the axis drawn. Okay. Now we need to plot the points. For x equals to -1, I need to plot -1.5 for y. -1 and -1.5. In between 0 and -3, we are going to have -1.5. So this should be the point. -1 corresponding to -1.5. Then 0 corresponds to 0.5. 0.5. This would be positive 1.5, and in between, like, this would be something here, 0.5. 0.5. Then that means we need to have, for 1, the value of x is -1.5 once again. So that would be a point here, 1 and -1.5. Then it is 2 corresponding to -7.5. So in between -6 and -9. We are expecting -7.5. So this would be the point. And then finally, x equals to 3 corresponds to -17.5. So -17.5 would be somewhere here. So these are the points according to the table of the values that we have chosen. Now we just need to join them using a smooth curve. So let me do that. And it would be a graph looking like this. So that's the sketch of this graph. So we can write down the equation of this graph along with it. Y equals to -2x squared plus 1/2. And since we had to label the x-intercepts and the y-intercepts, so let them be labeled. Let me label them with this. This is one of the x-intercepts. This is the other. And since we had the x-intercepts valued to be -0.5 and 0.5, so I can write down, better to write down like this, -0.5, 0. That is one of the points. This point is x 0.5 and y 0. And finally, the y-intercept. Y-intercept, we found it from this as well as from the graph and the table of the values. X0 corresponds to y equal to 0.5. So this point would be 0 and 0.5. So we are done with the x-intercepts and y-intercepts labeling, the labeling of the graph with its equation, and the graph is there. So that was part G of question number 1. Now we are gonna start solving question number 2. Let me have its part A, which states that sketch the following graphs, indicate the axis of symmetry, which is also known as line of symmetry, and then the coordinates of the turning point on each case. Okay. Okay, this is part A now. You can see the given equation is y equals to x squared plus 6x minus 5. So we need to sketch the graph. For sketching, let's first of all factorize it. The factorization method is like, for example, x squared, and you need to have the middle term breaking method. Like, for example, you need to have splitting this middle term 6x into two of its factors. The factors of 5 are 1 and 5. So I can write it down plus 1x plus 5x minus 5. Would it be? No, actually it won't work. It won't work. What we need to do, we would be just simplifying it in a way. We can use the quadratic formula to solve this thing because it is not factorized like in the form of middle term breaking method. Okay, let's compare this one, x squared plus 6x minus 5 with the ax squared plus bx plus c. the general form of a quadratic equation. So comparing them, the coefficient of x square is a. So the value of a in this case is 1. The value of b is 6, which is the coefficient of x, like this. Then c, the constant, that is -5. So c is -5. So once we are done with this, let's substitute the values in the quadratic formula, which is x equals to -b plus minus. Substituting this value, negative times b is 6 plus minus square of 6, which is 36, minus 4 times a, which is 1, times c, which is -5, divided by 2 times 1. Okay. Now this is -6 plus minus 36 plus 20, square root of this divided by 2. So you can have -6 plus minus square root of 56 divided by 2. Okay, now you need to calculate the square root of 56. And we need to have the square root of 56 now. Square root of 56 would be 7.48. Okay. 7.48. So this is 6. 7.48 divided by 2. So now you can have two values of x. -6, -7.48 divided by 2. And one value is going to be -6 plus 7.48 divided by 2. -13.48 divided by 2. So we need to divide it by 2. -13.48 divided by 2. -6.74. And then solving the other value, this is 1.48 divided by 2. That would give us 0.74. So these are the two values of x. Actually, these are the x-intercepts, where the graph is going to cut or intersect the x-axis. -6.74 and 0.74. Now, in the same way, I need to have its y-intercept. Now, y-intercept would be the point where the x coordinate is 0. So I'm going to replace 0 squared plus 6 times 0, -5. So the value of y is -5. So this is the y-intercept. Now, axis of symmetry. Axis of symmetry, line of symmetry. There are two methods to understand this line of symmetry. One method is actually the line of symmetry means the point that would be in between the x-intercepts. So this point and this point, the point which is in between these 2 points, when you are taking a point which needs to be halfway between these 2 points, so you need to have their average. So for the line of symmetry, we can have negative 6.74 plus 0.74 divided by 2. So that is actually negative 6 by 2, that is negative 3. So the equation of the line of symmetry could be x equals to negative 3. That means the graph would look like the same on both sides of x equals to negative 3. Like for example, if the graph is going to be like this and this is its line of symmetry, so this line is going to be x equals to negative 3. So this is the concept actually. And then we need to locate the coordinates of the turning point on each graph. Turning point, when we are talking about this turning point, that means we need to substitute this value of the line of symmetry into the given equation. So this x equals to negative 3 is going to be substituted into the given equation. So that would give us y equals to negative 3 square plus 6 times negative 3, negative 5. So positive 9, negative 18 minus 5. So this is negative 9 minus 5. Y equals to negative 14. That is its turning point. The turning point is actually x comma y, that is negative 3 and negative 14. Okay, now combining all this information, let's sketch the graph now. Okay, the sketch is going to be something like this. Okay, x and y axes are there. Now you need to locate y-intercept. Y-intercept was y equals to negative 5. So this is negative 1, negative 2, negative 3, negative 4, negative 5. Okay, one thing. So the point is going to be this one. Okay, then the x-intercepts, one of the x-intercept was 0.74. So you can have, if this is 1 here, on the left side, we are going to have negative 1, negative 2, negative 3, negative 4, then negative 5, and then negative 6, negative 7. In between negative 6 and negative 7, this is going to be negative 6.5. And now in between this is going to be somewhere the required point x equals to negative 6.74. Now for this x equal to positive 7.4, you see in between 0 and 1, this is 0.5, and in between 0.5 and 1, this is almost 0.74 here. So we have drawn these three points, the y-intercept and the two x-intercepts, and then we need to have this line of symmetry also. Line of symmetry means this is the line on both sides of which we are going to have the same graph. So this is the line of symmetry. And then the turning point was, if you concentrate on that, that was negative 3 and negative 14. So x is negative 3 here, and negative 14 would be somewhere down. So joining all those points from there, The point is going to be like this and like this. But it is since not the turning point or the minimum point. So if I can rearrange or reiterate the y-intercept and its y calibrations. So let it be, I need to have -14 accommodated. So it can be -2, -4, or even I can have a gap of 4. So -4, then -8, then -12, and it would be -14 here. And for that y-intercept, that was negative 0.5, that was here. So joining them together, now this is the minimum point. This one and this one. So this is the graph of the required equation. So you can write down y equals to x squared plus 6x minus 5. This is the x-axis, this is the y-axis, and so on. So all the working is there.